Okay, so ladies and gentlemen, you are welcome. In today's video, we are going to look at the concept of Gay-Lussac's law of combining volume. So this Gay-Lussac's law is a law that trying to describe the combining of gases that react together. So generally, we have a lot of gaseous substances that react together. So the Gay-Lussac's law is a law that trying to describe the combining volume of the gases during the course of a chemical reaction. So in this experiment, this Gay-Lussac's law will try to keep the temperature and pressure constant. So what happened when he kept the temperature and pressure constant? So he stated that the law said that the volume of gases which take part in a chemical reactions bears a simple whole number ratio to one another and to the volume of the products if they are gaseous when assumed at room temperature. So you can clearly here see that we have some gaseous substances, which is hydrogen gas and chlorine gas. So the hydrogen gas and chlorine gas here react to produce hydrochloric acid as also a gas molecules. So according to this law, it stated that the gaseous reactant as well as the product generated, the actually bears a simple whole number ratio to one another. Like for example, if you look at this one here, the the moles of hydrogen here is 1 mole. So we have 1 mole of hydrogen react with 1 mole of chlorine to generate 2 molecules of hydrochloric acid. So you see ratio 1 of hydrogen react with 1 ratio of chlorine to produce 2 ratios of hydrochloric acid. So this is to tell you that they are actually combined in a simple whole number ratio. So the number, they are very simple and they are very small. So that is what this law is trying to actually describe. So 1 mole is equivalent to 1 volume. So that is why as we have 1 mole here, we can say it is something as 1 volume of hydrogen gas plus 1 volume of chlorine gas to give 2 volumes of hydrochloric acid. So this is actually what this scientist is trying to describe. He tried to describe the relationship between volume and moles. So they are related. And of course, remember that according to the Avogadro's law, he stated that the equal volume of all gases contain the same number of molecules. So this is to show that there's a strong relationship between volume and molecules. So 1 volume means 1 mole because they are directly related. So there is a strong relationship between Gay-Lussac's law and Avogadro's law of combining volume, because according to Avogadro's law, he tried to actually show the relationship between moles and volume. So therefore, 1 molecules of hydrogen means the same as 1 volume of hydrogen. So that is actually according to Gay-Lussac's law of combining volume. So I think without wasting much of our time, we can actually look at some examples and get the solution. So let's look at these examples. So example 1, the question says what is the volume of oxygen required to burn completely 45 grams of methane, sorry, 45 centimeter cube of methane. So I think it's simple. We need to drive the equation of the reaction first. What is the volume of oxygen required to burn completely 45 centimeter cube of methane? So the first thing we need to actually drive the equation. So methane is CH4. So when methane, which is CH4, burn in the presence of oxygen, that is oxygen gas, then it will now, of course, this is a combustion reaction. So whenever we have combustion reaction, usually we have, especially with hydrocarbon, we generate carbon dioxide and water as the product. So we now have carbon dioxide plus water molecules. So the next thing is to balance the equation. So we have 1 carbon here, also 1 carbon here. We have 4 hydrogen here, and we have 2 hydrogen. So we need to add 2 here. Then we have 2 oxygen here, and we have 2 oxygen and 1 here, making, sorry, 2 here, 2 here, making 4 oxygen at the product. So we need to add 2 here. So we need to add 2 more. So you see, the whole number ratio or the moles here, you have 1 moles of methane plus 2 moles of oxygen to produce 1 mole of carbon dioxide. So the question says, what is the volume of oxygen that is required to bond completely with 45? So you want to get the volume of oxygen, while the volume of methane is already given as 45 centimeter cube. So to know exactly the volume of oxygen that is required to calculate, to bond the methane completely, so we make it X. So we now have the relationship 1 mole into 2 moles of oxygen, then 12 centimeter cube of methane into X centimeter cube of oxygen. So we now cross multiply at the end. We are now going to have X is equal to 45 times 2. So we have 45 times 2. So we cross it, this one times this. Then we now have 1 times X, which is 1 mole. So we divide it by mole. Then at the end, we are now going to have 90 centimeter cube of oxygen. So it means that you need 90 centimeter cube of oxygen to completely bond methane into carbon dioxide and water. So this is actually for the first example. So let's look at another example. So this is example 2. We have 20 centimeter cube of CO, that is carbon monoxide reacts or as packed with 20 centimeter cube of oxygen. So if all the volumes of gases are measured at STP, then calculate the volume of residual gases after sparking. So we want to now calculate the volume of residual gases after sparking. So how do you do it? First, we need to also derive the equation of the reaction. So we have CO, that is carbon monoxide, spark with oxygen, and at the end, we are going to generate 2 molecules. So we are going to generate, of course, carbon dioxide. So the carbon 4 oxides. So this is the equation of the reaction. So we have to balance this. So we have 2 molecules of carbon monoxide react with 1 molecule of oxygen to produce 2 molecules of carbon dioxide. So the next thing is to derive the mole. So we have 2 moles of carbon monoxide, and then we have 1 moles of oxygen to produce 2 moles of carbon dioxide. So we have this. So first, what is the volume of all the gases before sparking? So see, the volume of of carbon dioxide is given as 20 centimeter cube. And then of course, the volume of oxygen is also given as 20 centimeter cube for the spark. And then of course, the volume of carbon dioxide is not given. So it's not given, so we use hyphen. So it's not given. So this is the volume before sparking. That is before the reaction start taking place. So what happened during the sparking? What happened during the sparking? So we need to know that here we have 20 centimeter cube here when sparking. And of course, by looking at the number of molecules of carbon dioxide and oxygen, they are not the same. So since here we have 2 moles of carbon dioxide and we have 1 mole of oxygen, so during this packing, they are not going to contain equal volume. They are not going to have equal volume. So we have to follow Avogadro's law. So here we have 20 centimeter cube. So if 2 moles of carbon dioxide gives 20 centimeter cube, so what happened when we have 1 mole of oxygen? It means that it is going to be half. It's going to be half. So therefore, since here is 20 centimeter cube, so here is going to be 10 centimeter cube, because the volume of oxygen is half the volume of carbon dioxide, or the molecules of carbon monoxide is half. So the volume of oxygen is half the molecules of carbon monoxide. That is why it is now 20 centimeter cube for oxygen. And then what will be during the spiking the volume of carbon dioxide here? So because carbon monoxide and carbon dioxide contain the same volume, so it is going to be 20 centimeter cube. So that is what we have. So after the spiking, what we have after the spiking, what is the volume remain? So you see 20 minus 20, we have 0 here. Then 20 minus 10 here, we have 10 centimeter cube left here. That is 20 centimeter cube of oxygen remain unreacted. So it doesn't react. Then we have, of course, during before the spiking, the volume is there is no any volume. Then after the spiking, about 20 centimeter cubes of carbon dioxide is produced. So it means that there is a 30 centimeter cube of carbon dioxide that are produced. So now, what will be the volume of the residual gases? So to calculate the volume of the residual gases, the volume of the residual gases, to calculate the volume of the residual gases, then we are now going to say the unreacted gas, the volume of unreacted gas, the volume of unreacted gas plus the volume of the products, So therefore, the volume of the unreacted gas here is 10, and then the volume of the product is 20. So 10 plus 20 is now going to give us 30 centimeter cube. So ladies and gentlemen, this is the residual volume of gases after speaking, and I hope you find this video very interesting, and thank you very much. If you didn't subscribe and join the YouTube community. See you next time.